Hey there, welcome back. We're going to move on to a section where we learn how to graph a system of inequalities. Remember, when we have inequalities, we have shading that occurs. So we have to get the boundary line, we have to test a point, and we have to shade. And some of our problems could also include absolute value. Okay, so here's what we're going to do when we solve a system of inequalities. For each inequality in the system, we are going to sketch the boundary line. Okay, if you're at a line, you're going to have x-intercept, y-intercept, slope. If you have an absolute value, you could have, if you have an absolute value, you would be looking for the vertex and then points to the left and to the right. I'm going to do an example of that. Okay, then you're going to test an easy point. Test an easy point, shade the half plane that contains the solutions, and then in order to solve the system, you have to look for where the shading overlaps. Where the shading overlaps, okay? So if you use colored pencils, which this is kind of fun to do, you want to look for the area that has all three colors, okay? Or however many colors. You could have 2 colors, you could have 3 colors. Could have 4 colors, but you want to find the place where the shading overlaps. So let's start really simple. All right, let's graph the inequality y is greater than -4. Remember, when we do this, we start with the equation to get the boundary line. So I don't have an x-intercept because this is a horizontal line. My y-intercept is 0, -4, and my slope is 0. So if I test a point, say 0, 0, I would have 0 is greater than -4. Well, that's true, so we would shade towards that, towards 0, 0. So here is y is -1, -2, -3, -4. This is a dashed line. Make sure you can see it. Okay, and I have to shade towards 0, 0. So that means I'm going to go all up this way. Okay. Do this shading light. Do this shading light, and then your overlap, you want to do that darker. For x is less than or equal to 3, remember we're going to graph the boundary line. X equals -3. My x-intercept is -3, 0. My y-intercept is none. My slope is undefined for every vertical line. And then I want to shade. I'm going to test 0, 0. So 0 is that less than or equal to 3? Well, that's true. So we're going to go toward. Here's my line. This is a solid line. X equals 3. Okay, trying to make that strong so you can see it. Okay, there's my line. And then I have to shade to the left. I have to go towards 0, 0. So do you see where my purple shading overlaps my red shading? That's the solutions to my inequality system. So all in here. This is this like square area right in here. It doesn't include any part on the graph that has only one color or no colors. Let's try a little bit harder. Let's go back to a purple pen, and let's do y is greater than 2x minus 4. So my x-intercept, I'm plugging in 0 for y, and that means that x is equal to 2, so it's 2, 0. And my y-intercept is going to be 0, -4. My slope is 2, or 2 over 1. And if I test 0, 0, I get 0 is greater than -4. Well, that's true. So I'm going to shade toward 0, 0. I'm going to do that in purple. So here's 2, 0. Here's 0, negative 4. And I'm going to use a dashed line on this. And then I have to check my shading. Okay, and I have to go towards. So I'm going to go this way. For this second equation, I have an x-intercept of, let's say I plug in a 0, the 3 moves over, multiply by negative 2, that's going to be 6, 0. My y-intercept is 0, 3. My slope is negative 1/2. And if I test the point 0, 0, I would get 0 is less than or equal to 3, and that's true. So I would go toward. So 6, 0, that's off my graph. I'm going to pick up with 0, 3 and use my slope of negative 1/2. It's down 1 over 2, down 1 over 2. I'm going to go up 1 over 2, up 1 over 2, and this should be a solid line. Now I'm going to shade it towards 0, 0, so that's going to go this way. And you see where my purple shading is overlapping my red shading? That's the area of the solution of my system. So here's where my solutions are all in this highlighted area. Okay, below the red line and to the left of that purple dashed line. Okay, these are my solutions. So sometimes it can be hard to see, so I would recommend your preliminary shadings you do light, and then you make your final shading dark, okay? Now this system, we have a line, that's a line, and then we have an absolute value. So this one's going to be a V. So instead of finding the x-intercept and the y-intercept, what we're going to find here is the vertex and then points to the left and to the right. But let's start with the line because it's easy. So my x-intercept, I move my 3 over, that goes negative, divide by negative 2, so that's 3/2, 0. My y-intercept is 0, 3. My slope is negative 2 or negative 2 over 1. And if I test 0, 0, which is not on the line, I would get 0 is less than or equal to 3, and that would be true. So I would go towards. And this is going to be a solid line. So I'm here, 1, 2, 3. And then it's got to be going downhill from left to right. So I would have a point here, down 2 over 1. Down 2 over 1, down 2 over 1, down 2 over 1. And this is a solid line going like this. And my shading on this one, my lighter shading, is going to go to the left towards 0, 0. Now I'm going to graph my absolute value. So remember when we graph an absolute value, to find the x-coordinate of the vertex, we set our argument equal to 0 and solve. Well, in this case, it kind of self-solves. And then we plug that in, and we get negative 2. So my vertex is 0, negative 2. And I put that in my center of my graph. I'm going to pick a point to the left, another point to the left, a point to the right, another point to the right. That'll give me a good shape. Negative 1, absolute value of negative 1 is 1. 1 minus 2 is negative 1. Plug in negative 2. Negative 2, absolute value is 2. 2 minus 2 is 0. And then symmetry gets me to the same numbers here. And then I'm going to graph this. So here we go here. Oops. Okay, and then I have 1, negative 1, and 2, 0. And I'm going to follow that slope just so that I make sure I capture a good piece of my graph here, here, and here, and I'm just going to follow that same pattern up, and then this should be a solid line. And now I have to test a point. So I'm going to test 0, 0 because it's not on my boundary line. And if I plug it in, I get 0 is greater than or equal to -2. Wow. And that is true. So I'm going to go toward 0, 0. That's between the lines. So here's my red shading. And what are we looking for? Where our purple shading and our red shading overlap. So it's kind of this funky little section right in here. Okay, let's keep moving on. This one's kind of a fun one. Let's graph the first one, my x-intercept. Let's see, what color do I have? Let's do purple. Is -5, 0. My y-intercept is 0, 5. My slope is 1. If I test 0, 0, I get 0 is greater than or equal to 5. That is true. So I'm going to shade. Is 0 greater than 5? Oh, that's false. My bad. False. It's getting late. So I'm going to shade away. Okay. So I would get here, and I would get here, and I'm going to make a solid line connecting those two. There's my boundary line, and I'm going to shade away. Okay. Now I'm going to graph this line. Y is less than x minus 4. My x-intercept is 4, 0. My y-intercept is 0, -4. My slope is 1. I'm going to test the point 0, 0. Go up here. 0 less than -4. Well, that's false. So I'm going to shade away. This can be a dashed line. So here's 4, 0, my x-intercept. 0, -4. There's my y-intercept. Now I'm going to make a dashed line here. And then I have to shade away. So where do my two colors overlap? They don't. So that means there's no solution. No solution. Okay? All right, now we're going to apply this process in context. So let's read this application. The Rogers, Mr. and Mrs., are driving across the country. They, so that means Mr. Rogers and Mrs. Rogers, plan on driving a maximum of 10 hours. That means they could drive 10 hours or less. All right, so if we let X be what Mrs. Rogers drives and Y be what Mr. Rogers drives, X plus Y has to be less than or equal to 10. Okay, that's how I interpreted that red statement and got this inequality. Now we have another constraint. It says Mr. Rogers, I abbreviated that Mr. R, wants to drive at least 4 hours. So he could drive 4 hours, he could drive 5 hours, he could drive 6 hours, 7 hours, all right, and then it says, but no more than 8 hours. He could drive 8 hours, but no more than that. So that's how I got this statement here. Y is between 4 and 8. Then my last statement is Mrs. Rogers can drive between. Between is exclusive, so cross out those little these little things here, the equals, okay? And our x's are going to be between 2 and 5, okay? So what we're going to do is we're going to graph each of these. So I'm going to let each one of these things be 1. So here's 10 and here's 10. And my line for the first equation, inequality, is going to go like that, okay? And we have to shade, right? So it's 0 is less than or equal to 10. That's true, so we have to shade this way, okay? Now, this I'm going to get 2 lines. We're going to get 2 lines. The first one is y is equal to 4. 1, 2, 3, 4. So here's this line right here. And then y is equal to 8. 5, 6, 7, 8. And we want our y's that are where? Between that. So we're going to shade in between those 2 lines. Remember, we're looking for overlap. So you see out in here where there's just blue, that's not going to be part of our solution in the end. All right? And then we have this purple line right here. And there's 2 lines there. X is equal to 2. So let's draw a dashed line here. And 5, 3, 4, 5. And let's draw a dashed line here. Remember, X's are vertical lines. And then we're going to shade in between. So we're going to shade in between. What are we looking for? And it's hard to see on this one because there's so many colors. All right. We're looking for where all 3 colors overlap. Purple, red, and blue. And if you notice it, it's right here. Let me get my highlighter out. It's here. And it makes like okay, here we go. All right, our last example, we're going to, I think, let me see, is that our last example? Yep, this is our last example. So what we're going to do is we're going to graph a system of 3 inequalities, and then we're going to identify the vertices, okay? So let me set my pen to purple. 2x minus y is greater than -1. So my x-intercept, plug in 0 for y. So that means I'm going to get -1/2, 0, comma 0. My y-intercept is 0, comma +1. My slope is -2 over -1, which is 2. And if I plug in 0, 0, is 0 greater than or equal to -1? True. Towards. Okay. X plus y. Let's go ahead and graph that. So I have 0, 1. And then I have +2 slope. So I have up 2 over 1, up 2 over 1, up 2 over 1, down 2 over 1, down 2 over 1, and this should be a solid line. Okay. All right, next equation, I'm going to do that one in red. Which way do we want to shade? Towards, right? So let's get our shading in here. Remember, do these light in the beginning. Now I'm going to pick red. My x-intercept is 4, 0. My y-intercept is 0, 4. My slope is -1. If I test 0, 0, I have 0 is less than or equal to 4. That's true. So I'm going to go towards. True, towards. So I have 4, 0. 1, 2, 3, 4. Here's that point. And 0, 4. 2, 3, 4. Solid line. And I have to shade towards. So remember, what are we looking for? We're looking for where they overlap, so we're not going to include that red part up there, only where they overlap. Okay. Third equation, let's flip to blue. I have an x-intercept of 4, 0, a y-intercept of 0, 1, m is equal to negative 1/4, and if I shade as 0 greater than or equal to 4, that's false, so we're going to shade away. Right? So I have 4, 0, okay, and I have, oh sorry, my bad, I'm tired, that's not right. 4, 0 is on the other axis there. Here's 4, 0, and then I have 0, 1, and then it's a solid line between them, and then I have to shade away. So I'm going to be in here, right? So let's get my highlighter out, and let's shade in this triangular region right here. Okay, so what are my vertices? Well, I'm going to have the point 0, 1, that's this point, and then I'm going to have 1, 3, and then I'm going to have the point 4, 0. All right, so these are the problems that we're going to work on in class, our daily assignment. Thanks for listening. I'll see you then.